This video covers Module 4 Part B, Data Cleaning and Descriptive Statistics. In this video, what I want to do is start to go through the data analysis that you need to understand in order to be able to write up your quantitative project report. There are two videos for writing up the analysis for that report, and this is the first. The next one will come in the next video. In this video, we're going to talk through cleaning and editing the raw data, and then also providing descriptive statistics for the data set. So when we're talking about cleaning and editing the data, what we're really talking about here is tidying it up in order to make sure that it's usable and it's going to give accurate results when we analyze it. So we'll go through and we'll do things like change text-based responses to numbers if people have inadvertently entered text instead of numbers, so that we can start to do calculations with them. And we might also go through and just check that the numbers that have been entered by the researcher, for example, look realistic and meaningful, that nothing's out of range. We do that sort of stuff. In the second part of this lecture, we're going to be talking about descriptive statistics. Now, these are the basic form of statistics that describe your sample or describe your data set, hence the term descriptive statistics. So you think about means and standard deviations, minimums, maximums, those sorts of things. These are stats that you provide to the reader so that they understand what your data set looks like. What we will be looking at in the next video then is inferential statistics, which build on the descriptive statistics, where we conduct analyses like t-tests, correlations, and so on, in order to infer something from our data set about the broader population. Okay, that's the next video. So in this one, we're talking about cleaning and editing the data and descriptive statistics. So a couple of notes before we get started. One thing I'll say is that AMB 201 is not a data analysis subject, and we know that we've got a huge range of people in the unit, some who have data analysis experience, some that don't. So just a heads up, we don't assume that you have data analysis knowledge, and we don't expect you to learn in detail the data analysis techniques or the underlying ideas behind the techniques. What we do is go through these conceptually so that you understand what was done with the data in order to arrive at the results that we obtained. You're not expected to perform the analysis yourself. It's all done by the AMB 201 teaching team. We produce a document that you can get those results from, but these lectures are essentially a way of providing you with an understanding of where those numbers come from. Right, so I guess if you're planning on going into any sort of career with data analysis, something like this is quite handy for you, because you're getting a bit of background to where some of the numbers from data analysis come from. All right, so we'll be going through the data analysis procedure and the actual results that we obtained from our data set in order to answer the research objectives, or address the research objectives and answer the research question for our quantitative project report. There's a document up on Canvas already, which will describe all of the results and provide you with the actual numbers that you need to use or incorporate into your report, and also an outline of what you need to do. And we'll also be talking about that in this video. So just a heads up, don't stress about this. This part of the unit is not intended to stress anyone out. It's really giving you that background of data analysis that's associated with quantitative research. So if you haven't looked already, there are a number of new documents up on Canvas already. We've got a constructs document. The data sets that we're going to be analyzing are up on Canvas already, a variable codes document and an analysis document. So let's have a look at those documents. If you go through to modules on our data on our Canvas page, and then go down to quantitative project report, which you would have looked at already, a section of the site you would have looked at already in order to collect your data. We've got three final documents and some data sets listed here already. So the first one is a constructs document. If we have a look at the constructs document, you can see that this document responds really quite closely to an activity you would have done in tutorials a few weeks ago. And this is basically a document that describes the constructs in our study and the variables or questions within our survey that feed into each of those constructs. All right, so it's going to outline the focal construct, which is attitudes towards smartphone shopping, and which we measured in terms of affective attitude, cognitive attitude, and behavioral attitude. If you've done consumer behavior, you'll know that attitude is typically conceptualized in those three dimensions. It will also outline the variables and constructs associated with objective 1, so how we can split the population up into different segments to inform our analysis. It will outline the constructs and variables associated with each of these individual characteristics. Will help us address objective 2, and for objective 3 it will also outline what items within the survey fed into the constructs that are going to allow you to answer objective 3. So if you scroll down here, you can see here we've got attitudes towards smartphone shopping, those 3 affective, cognitive and behavioral intention dimensions listed there, and under each of those you've got the 4, in the case of affective attitudes, the 4 items within the survey that fed into that, within cognitive attitudes the 5 items that fed into that, and within the behavioral intention dimension the 3 items that were in the survey that fed into that construct. Scroll down here further and you can see we also were interested in the construct of convenience seeking. We measured that with these 7 items that were located within the survey. So thinking back to one of the early tutorials, we talked about that when we're writing up a report, it's important to state the concept or the construct you're examining, provide an operational a conceptual definition, and then also outline your operationalization of that construct, and that's essentially what you've got here. So we've got our statement of the construct, our conceptual definition of what it refers to. So this refers to a trait of people searching for ways of achieving tasks with minimal difficulty, and then we operationalize that by asking these seven questions. And what essentially we go through and do is look at people's responses, say on a 1 to 7 scale to each of those questions, and take an average across those numbers in order to work out their convenience seeking score. Scroll down here, you can see the same thing for risk aversion, impulsiveness, we've got these 4 items, price consciousness, we've got 4 items, enjoyment, 3 items, and so on. Scrolling down here, you've also got the survey items that corresponded to general attitudes toward the 2 different modes of shopping that we're going to look at for objective 3, so online shopping and then traditional in-store shopping. And over on this final page we've also got the concepts or constructs that will help feed into our overall analysis for objective 1, which relates to things like relationship status, gender, and age cohort. You can essentially see all of that within this document. We've got a variable codes document up on Canvas now, and that's a little bit similar to a constructs document, but here what it provides is a bit more specificity around how we use or how we code up each of those items within our actual data set. So obviously if we're talking about particular items within our survey, we wouldn't read out or label it as the entire question or the entire statement here because it becomes too cumbersome. Instead what we do is label them with some sort of code that allows us to refer to that. So whenever we're talking about attitudes, we would typically use an ATT type abbreviation, and then if we're thinking about affective attitudes, we'd add an A to that, cognitive attitudes add a C to that, and behavioral intention add a BI to that. So ATTA, ATTC, ATTBI, and the items that fall under each of those dimensions are listed here. So you can see for affective attitudes, ATTA1, ATTA2, 3, 4, and so on. So scrolling down here, you can see the same thing with all of the other constructs. So for convenience seeking, we've got those 7 items labeled CS1 through to 7. On this page, you can see that some of the items are highlighted in yellow, and they have a little asterisk here as well. What these refer to is that those items are negatively worded or negatively framed. You might remember back from module 3, we talked about this idea of reverse coding items or reverse wording items or negatively framing items in order to serve as a little bit of motivation for people to read or respondents to read the survey more closely, reduce fatigue, and to also identify if people aren't paying attention. So here you can see that these, for impulsiveness for example, that the first two items are positively framed. So someone high on impulsiveness would respond, say, 7 out of 7 on each of these top first two. So I often make unplanned purchases. An impulsiveness person might say yes, 7 out of 7. I like to purchase things on a whim, yes, 7 out of 7. And then these next two are reverse coded. So someone who is high on impulsiveness, you'd expect to respond down the lower end. So I tend to think twice before committing myself to a purchase, and I always stick to my shopping list, so things that aren't really impulsive. So a highly impulsive person might respond 1 and 1 there. So in order to have a measure of impulsiveness, what we would typically do is average the responses that people give, and it's important to be aware of which ones are reversed, because what we need to do with those reversed ones is flip the responses around. So a 1 becomes a 7, a 2 becomes a 6, a 3 becomes a 5, and so on, before we take that average. Right? Otherwise, a 7, 7, 1, 1 gives you a score of an average score of 4, which isn't 4 out of 7, which isn't doesn't indicate high impulsiveness. Right? So once we flip those around, it would become 7, 7, 7, 7, an average of 7. All right, and scrolling down, you can see all of the other coding for those items that we ran within the survey, and you'll see that within the data sets in a moment. We've got the analysis document on Canvas here as well. So if you open that, you'll see this is the document that provides all of the analysis and the results and the descriptions of what you need, or the templates, if you like, of what you need to write up for your actual report. So on this front page here, it gives you an overview of what your analysis section should look like. So you're going to talk a little bit about data cleaning, so cleaning and editing. So that's going to be a few sentences. Descriptive statistics, which again is going to be a short section providing the descriptive stats for your data set. Talks about what to do for the analysis for objective 1, for objective 2, and for objective 3, and then for each of those sections the report goes through and outlines what was actually done and what results were obtained. So this is how we cleaned the data. We deleted particular respondents or changed responses to be more meaningful and in line with the remainder of the data set. Down here you can see a description of how we've gone through and reverse coded those negatively worded items, and how we've gone through and calculated the construct. So for example, we added all of the convenience seeking items together and then divided by 7 to get an overall convenience seeking score. Down here you've got your descriptive statistics table and some other stats that we'll talk through momentarily. So back on Canvas, what you can also see here is the actual data sets that we used. So your raw data set, and remember, you don't actually need to do the analysis, it's all been done for you, but this is provided on Canvas for you, so that if you do want to have a look at the data and you do want to maybe perform some additional analyses, that you can do that if you want, but that's not necessary. Right, so this is our raw data. When you went to Canvas and clicked that link and entered your data, it essentially went into a class database that generates a spreadsheet that looks like this. So the very first person who responded to the 18 to 40 years survey, the first person here, their responses are listed across the table here. So the particular items, so when making a purchase, I would rather be safe than sorry, are listed in columns. Right? I enjoy interacting with others when I shop, and each of the individual respondents are listed in rows. Right? So that first person gave a 7, then a 3, then a 6, then a 2. For the second survey respondent, they gave a 6, a 4, a 5, a 4, and so on. If you scroll down to about halfway, you can see in this raw data set, you've also got the second group of survey responses as well. So 41 plus years. First respondent answered a 5, a 7, a 2, and so on. So that's your raw data set. This is data as entered by class members. If you scroll along here, you can see why you need to start cleaning and editing data. People are responding a little bit inconsistently, and we need to go through and make sure these responses are accurate or can actually be entered or used in analysis to produce reliable results. The cleaned data set then, which is also an Excel file, is the data set where that data has actually been cleaned. So across the top here, you can start to see the actual variable codes that we've used, and they're listed in that variable codes document that I've just spoken about, which makes them a little bit more meaningful to use, or the data set a little bit more easier to talk about. You can imagine talking about the first few items within a survey. If we list them by these entire labels, it's quite cumbersome, as opposed to just talking about RA1, SOR1, and so on. So risk aversion 1, impulsiveness 1, convenience seeking 1, and so on. Right. Within this data set, we've also got tidied numbers, so you scroll along here to where those inconsistent responses were, and you can see that they're now have been tidied, and we'll go through in a second to talk about how that was actually done. Also on Canvas now is our SPSS cleaned data file, and that's the package that we'll be using to analyze our data. So if we open up file, you'll see here it looks very similar to an Excel spreadsheet, very similar to that clean data file where we've got respondents across the in the rows and items, survey items within the columns. But what you actually have within SPSS, and I'll go through this in a bit more detail in a moment, is these two tabs down the bottom. So the data view is the Excel type view where we can see all of the actual data, and then the variable view goes through and lists each of those items that are in the column across here. So cohort, risk aversion 1, and so on, social orientation 1, impulsiveness, lists those in rows, and you can specify attributes of them. So it's a little bit of a record keeping tab here where we can go through and we can say that item was actually this question here. So RA1 or risk aversion 1 is, when making a purchase I would rather be safe than sorry. Social orientation is, I enjoy interacting with others when I shop. And then in the values field here, it goes through and lists the types of responses that people can actually give. So it's quite helpful for storing all of that data and allowing you to remember what feeds into each of those variables. So this is the package that we're going to be using to analyze our actual data. Right, so have a look at those documents and those data sets if you get a chance. Keep in mind, as I said, you don't need to perform the analysis yourself. It's been all done for you, but if you do want to interrogate that data a little bit or become interested in it, that data is there for you to actually have a bit of a play around with. All right. So a couple of notes before we jump into it. One thing I like to point out to people is that usually with data analysis, people have a perception that it is really about just producing numbers or performing mathematical operations or statistical calculations. And certainly that's part of data analysis. But if you look at it more broadly, what it's about is taking a set of numbers or a data set like the one here shown on the screen and converting it to meaningful conclusions. So good data analysis isn't so much just about doing the stats, it's about taking data and producing meaningful conclusions. So it's going one step beyond just producing the stats. So if you get employed as a consultant or a data analyst, no one wants you to go and perform a bunch of stats and just give them statistical output. No one's interested in that because they may not have the skills to interpret that. So what you're doing is running the analysis and then interpreting, often verbally or in graphical form, what that data means and drawing meaningful conclusions for those people. So as you're writing up your report, keep that in mind, that you're not just reporting numbers, you're not just reporting stats. What you're doing is interpreting that data set or telling the reader what that data set is basically about. All right, the way we will start to go through these couple of lectures is in the sequence of what you need to address in the analysis sections of your report. So we'll start by talking about cleaning and editing the data and then descriptives, and then we'll go through in the next video the results for Objective 1, Objective 2 and Objective 3. So let's start with data cleaning and editing. So the very first thing that I like to do when I'm starting to clean up a data set is to have a bit of a look at it and see the extent to which people have provided input that is a little bit consistent with other people. So obviously, if you're going through and you want to look at the average age of your respondents, you need everyone's age listed in a similar format, so listed as a number. You can't have some ages listed as a birth year, other ages listed as age in years, other ages written in text, for example. Everything has to be formatted similarly. So within our surveys, anytime people are free to enter responses as opposed to click a particular number, you open yourself up to inconsistency in the way that people respond. And we've done that within our survey quite deliberately to highlight just how frequently this occurs and the problems that it can generate. So usually you would come back and address it within your cleaning and editing stage, and this is where what we'll go through now. Other areas where within the survey people were able to enter responses, the number of hours that your respondents spent each week on the internet, using social media, the number of people they thought they emailed each week on average, and on average the number of people they believe that they chat with online, for example, through instant messaging. So let's have a look at some of the data that we obtained for that. And these numbers here, this little snippet is a condensed version of some of the results. We didn't really have responses quite as inconsistent as this throughout. I've just condensed that a bit to highlight some of these issues. You can have a look at that raw data set to see just how common they actually were. So what we did is go through, and what you should do anytime you're editing data, because you don't want to lose too much data, is go through, and if it's obvious what people had meant in their responses, then you go through and convert their response to what they intended. So here you can see this individual has listed 22 years, or the researcher in our case has entered that as 22 years. We'd go through and just take out that years so it's in the same format as everyone else. Here a person's clearly entered a birth year, so we'd go through and work out their age based on that. Again, someone's listed text, so we'd go through and delete the text. This person's listed an age in years and also their birth year, so we'd go through and just in this case make that 50. Over in postcode, now we don't actually use postcode in our analysis, but it is a good field to collect to demonstrate some of the problems that we have with these types of responses. And if it were something that you wanted to use, then you'd need to think about how you go about deciding what to include and what not to include. So here person's indicated Greenslopes, so you could go through and find the postcode for Greenslopes. Durack, you could find the postcode for Durack, and same for Paddington. So the first thing you do is go through and edit data based on what you think people actually intended, if it's obvious what they actually intended or their response to be. A lot of the time though, you get responses that come back to you as a researcher making a judgment call on whether or not you include them. So often what I will do if I see a number or an entry that indicates that people are not caring too much about the response that they're giving, or they're entering data in a sloppy fashion, or they're perhaps joking and putting nonsense responses, I will delete that respondent altogether. And that's what I've done in our case, so that we have a cleaner data set. So we know we don't have postcodes of 0. Open isn't a postcode. I'm not 100% sure what that means. This person has probably misentered data. If postcode was something meaningful to us, that could be problematic. We could infer that it's 4013 or 4035, but if we don't know, then delete that individual. Here someone's indicated age as 3. It's probably not a 3-year-old that they're surveying, so again I've deleted that respondent. So it comes down to researcher judgment. Anything you can edit, you should edit. Otherwise, delete the respondent if you think it indicates nonsense responding or sloppy data entry. Same sorts of things that you can see here with the hours that people spend on the internet and on social media, number of people they email each week and chat with online. A lot of people have indicated more information than what we necessarily need, trying to be helpful. So what we would do is, as a researcher, is go through and interpret anything that we can interpret to make sure that data remains in the data set. So 20 hours we would just change to 20. Anytime for me, anytime I see something like 100 plus or 20 to 30, I tend to take a conservative estimate. So 100 plus I would always just put as 100, 20 plus as 20, 20 to 30 I put as the more conservative estimate, so 20 here, 2 to 3 as 2, 10 to 20 as 10. And I use that consistently across all of my analysis so that I can't be criticized by someone coming back later and saying I'm selectively cleaning my data so that I produce a certain result. So one of the things you might have picked up when we're talking about cleaning and editing the data is that it does give the researcher a lot of leeway to perhaps be a little bit sketchy or a little bit unethical. You can imagine that if I wanted higher numbers with this sort of data set, that I could instead take the higher estimate for these types of values, and again you could be criticized for that. So often while we say quantitative data is more objective, there is still scope for researchers to be a little bit sketchy with that. All right, down here you can see people entering text-based responses that need to be converted to actual numbers. There are a few instances where people have indicated a response that isn't really meaningful, or we can't interpret, or might indicate sloppy data entry or people having a bit of a joke. So whenever I get something like that, I just delete the respondent altogether. So someone saying they're online all day and they chat with everyone, that they avoid social media, I think that's fine, but it's not what we're interested in this survey. These ones up here, again, a bit nonsensical for the question that was asked, so I just delete that person. My rationale, or delete that respondent, my rationale is that if they're having a bit of fun with that question or responding sloppily with that question, chances are they've done the same with other questions. Now, the only other one that's worth pointing out here is the final question that was in our survey, which asked people to list all of the devices that they access the internet from. And you can see here lots of people accessed from desktop computers and laptops and smartphones, fewer with a tablet, some through smart TV, some through a gaming console. And this final one, which is other, please specify, is always good to include because it will help you to identify anything that maybe you've missed within your list. And you can see here smart watches like an Apple Watch is something that's coming up a little bit that in future research you might want to consider as an extra category. So you go through and identify how relevant those responses are to what type of analysis that you're running. You might classify them, for example, with television back here into smart television if you were trying to calculate an average or a total number there. Others like NBN, for example, and VR or virtual reality, I'm not 100% sure that they would really constitute devices, so we'd perhaps exclude those if we were paying attention to that particular question. Then the final thing that we do when we're cleaning and editing the data is look at the actual numbers that people have entered and try to make sure that the data entry person has entered them correctly. And this is a really valuable lesson because people are really not great at entering large volumes of data from paper-based surveys into spreadsheets. So what we need to always go through and do is double check that they've been entered correctly. So for example, you can see here with each of these items, these survey questions that were measured or evaluated on a scale of 1 to 7, we've got some people indicating an 8, this person indicating 5, 5, 5, 5, 5, I don't really know why. And over here, someone indicating a 0 on a 1 to 10 scale. I think these were the general attitudes questions that were out of 1 to 10, or the bipolar scales that were out of 1 to 10. And this person's indicated 0, which wasn't a response. So again, these people probably a bit sloppy. I've gone through and deleted those from our data set. Another one that you often pick up with this is where people simply hit the same response all the way through because they're not particularly invested in the research. They're just looking to get it done. So it might be 6, 6, 6, 6, 6, 6, 6, 6, 6, and you as a researcher can decide what to do with that. Yeah, we didn't have too much of that within our survey. So that's basically the cleaning and editing that has been done with our data sets. And if you go and look at our raw data here, where we've got all of these things that are perhaps indicating that people are responding inconsistently. You can see the difference it makes here within our clean data set. We can now start to run our actual analyses based on that data. So it's our clean data that we then move into SPSS and perform our analysis with. During this stage, we also go through and do what's termed coding. Coding just refers to assigning numerical labels to non-numeric data. And that's often necessary because a lot of data analysis packages will only work with numbers, won't only work with numerical data rather than text data, or it's often called string data within these packages. And that's a good thing because people will often, when entering something like single or partnered across items, start to misspell it occasionally, and then that causes all sorts of problems. So within our data, what we've gone through and done is recoded anyone who's indicated they were single for the partnered or relationship question as 1, partnered as 2, men were coded as 1, women as 2, other as 3, prefer not to say as 4. This is also the time when we go through and recode all of those labels to the particular variable code. So that all occurs during this coding stage. Within that variable codes document that's up on Canvas now, you'll see all of those codes that specify what the responses that people gave were coded as within our data set. So in terms of where do you access the internet from, home, work, uni or other, we've got 1, 2 and 3 listed there. So you can refer back to this document if you ever want to work out what the codes actually meant, because you can imagine over time, if you were to come back to this data set in a year, or if you were to give it to someone else, they don't necessarily know, or you might not remember what 2 on an access the access variable was, or if you coded men as 1 and women as 2, or the reverse, right? So that's what where the variable codes document becomes very useful. And that's also the sort of information stored within this tab within SPSS as well. So you can see here, if we go down here to values for the sex variable, we've got man as 1, women as 2, woman as 2, other as 3, prefer not to say as 4. So it's also stored there as well. Where that's quite handy, if we go across to these, where those items sit within our data set, and go up here to this icon, this A to 1 icon within SPSS, we can start to toggle between the actual numbers and the codes, and we can get a good idea of each respondent based on, rather than actual codes, the actual labels that correspond to that. So this person was Australian, a woman, single, preferred to access the internet from home, preferred instant messaging, and so on. Alright, during this stage, this is also where we go through and reverse code any of those negatively worded items that I mentioned before. So because these are negatively framed, anyone's response that was a 1 should be changed to a 7, a 2 to a 6, a 3 to a 5, and so on, so that low responses are flipped around to become high responses, so that then they are all in the same direction, if you like, as the other questions. So within our actual data set, what we've done in order to see that or do that is created these R codes, and you do this within SPSS fairly easily. So up here we might have risk aversion 5, wherever that is, risk aversion 5, which we know was a reverse coded one, and scroll down here, you've got risk aversion 5 underscore R, which is reversed. So within our actual data set, we do have the original data stored, but towards the end of our data set, we've now created new variables, which are those other variables flipped around. So when we take, for example, a risk aversion, or want to calculate our risk aversion construct, we would use RA5 underscore R as opposed to RA5. Okay, so during coding is when we go through and do this as well. Now, as I've said, we will be conducting or have conducted our analysis using SPSS. If you're not familiar with SPSS, I'd suggest that it could be good to have a bit of a play around with it and just see the functionality of it, because you do come across reference to it quite a bit, and it is quite a handy package to have some knowledge about. So SPSS is one of the most commonly taught statistical packages within universities, mostly because it's menus based and gives output that's fairly user-friendly and readable. Others are SAS, which is more scripting focused or scripting based. Excel you can also do analysis within, but as you know, if you've used Excel, you need to get all of the actual codes exact. The R program is also scripting focused or scripting based. It's free and gives really good graphics. So that's another one that you might explore if you're interested in data analysis. So SPSS stands for the Statistical Package for the Social Sciences. It's actually owned by IBM. If you go to the SPSS website, you'll see that they might have a free trial. I think it's usually around 14 or 28 days. It is installed on all of the computer labs in Z-Block and in the computer labs around the university. So if you are in one of those labs, you can access that, or you can also access that via this link here, using a VPN if you're at home. So if you want to play around with it at home, you log into the QUT VPN, follow the links here through the Apps Anytime platform, and access SPSS that way. That's if you're interested. So keep in mind, you don't necessarily need to do anything with SPSS, but just be aware that that package is the one that we use and that you can have a play around with it if you like. Now, because it is such a widely used package, there are a lot of user manuals and instruction guides out there, and I've put a couple of references here to some of those. But what I would actually suggest is that if you ever want to do something in SPSS or get stuck, just go to Google and enter the question that you have. Guarantee someone has had that same question before, and you'll see lots of answers. It's a widely used package, and it's one of the advantages of using such a widely used package, because you can often draw on that knowledge base that's out there. So we've done a lot in terms of cleaning and editing the data, so creating our constructs and then reverse coding items and so on. And as I said, that's all been done for you, and you can see here on this screen how that has actually those calculations have actually taken place, and this is actually all in the analysis document. So for our construct of convenience seeking, we've gone through and added together all the convenience seeking items divided by 7. Risk aversion, added all of the risk aversion items, including the reverse coded one in place of the negatively word item, divided by 6. Impulsiveness, we've got impulsiveness 1, impulsiveness 2, impulsiveness 3 reversed, impulsiveness 4 reversed, divided by 4 to give our impulsiveness score, and so on. So if you then go to the data set within SPSS, what you can see here is we just have now one value for attitude, affective attitude, one value for cognitive attitude, one value for each person for behavioral intention attitude, one value for convenience seeking, one value for risk aversion, and so on. So rather than having all of these items back here that we need to work with, we actually now just have these several items that are going to allow us to perform our analysis. So whenever we talk about convenience seeking, we just use this this overarching average for each individual, rather than the 7 items that make up that that score. Right? So for this very first respondent, their scores are listed across here. For the second respondent, their scores are listed there, and so on. Alright, so rather than all of those dozens and dozens and dozens of constructs and variables that feed into the constructs that we're going to analyze, we now just have several that we need to work with, which makes that very user-friendly. One quick note that's actually very relevant for what you're going to be doing is that we measured attitude in 3 different dimensions, and I've gone through that already, and that's based on the idea from consumer behavior that we have those 3 dimensions of attitude. So affective is my emotional attitude, cognitive is my thought-based attitude, and then behavioral intention is how I act in relation to my attitude, and the items for that here. For our purposes, to keep it simple, anytime we talk about attitude, we're talking about the behavioral intention. We're going to talk about the behavioral intention dimension of attitude. And if you want to go back and analyze some of the relationships based on these other dimensions of attitude, you're more than welcome to do that. The data is there for you. But for our purposes, all of our analysis is going to be based on the behavioral intention dimension. So anytime you're making an interpretation, come back to the actual items and think about what the actual items mean. But keep that in mind. We're just looking at the behavioral intention dimension of attitude for our purposes. So there's a lot that has fed into cleaning and editing the data, but within your actual write-up, usually it's only a few sentences that summarize all of that. And you'll find that in most research studies that a lot of work goes into cleaning and editing to make the data set ready, but that's not really detail that the reader is interested in. Most readers assume it's being done properly. So that's important, but in terms of your actual write-up, it's usually only a few sentences. So that's also what you're going to do. So you make within a few sentences, make some notes about the types of edits that were made, the types of removals that were made, that we had reverse-coded items that fed into our constructs, and how the constructs were calculated. Okay, so to write up your cleaning and editing section, just a few sentences summarizing those things is sufficient. The next section of your analysis then is going to be about descriptives or descriptive statistics. And again, this is just going to be a few sentences supplemented with some tables that show the actual results. So remember, tables don't count towards your word count, sentences do. So you can include a lot within those tables. So what are descriptives? As I said at the outset of this lecture, descriptive statistics are those that basically summarize or describe your data set for a reader, so that the reader knows what your data set looks like, knows general attributes of the constructs that they're working with. So means, standard deviations, minimums, maximums, ranges, those sorts of things. The next level up of statistics then is inferential statistics, which is where we use the data set to infer something about the wider population. Now, one of the first things that's really quite useful to do when you're providing descriptive statistics is to provide a table that summarizes the key characteristics of the constructs that you've got in your data set, and breakdown of different groups, for example, the number of people within each of the groups that you want to examine. So a table like this shown on the screen captures all of that information and can be generated really quickly through a program like SPSS. So let's have a look at SPSS, and I'll show you how to go about producing that table. I'll move slowly so that you can see what it is that I'm pressing. So we go to Analyze, and that menu provides all of the different types of analyses that you can run within SPSS. You go down to descriptive statistics, and you can see all of the different types of descriptive statistics that you can generate. We want a descriptives table, so we select descriptives. What we want to do is scroll to the bottom where we've got all of those constructs that we just created within the data set. So remember, they're at the end of the spreadsheet or end of SPSS file, so they're listed here, and we select the ones that we want to create a descriptives table of, or want that to include. So we select those, use this arrow here to take them across to the working window, and we click OK, and you can see it generates that table that I have just shown you in the PowerPoint slides. So what it shows here is each of the constructs that we're interested in, so the behavioral intention, attitude, construct here, convenience seeking, risk aversion, impulsiveness, and so on. You can see in each of those, feeding into each of those constructs is 436 observations, or data from 436 individuals. The minimum score and the maximum score, remember these are the averages of all of those items that form each of the constructs. So with convenience seeking, the smallest score that anyone got was 1.71, and the higher score was 6.71. Risk aversion, lowest score was 1, maximum was 7. This is really where you'd be able to identify as well if some of these variables had data points coded that were either too high or too low. If someone had entered 66 or 67 instead of 6 and then 7 in different cells, it'd show up here because the maximum would then be really quite high. Within this table, you've also got means and standard deviations. So remember, your mean is just the average score that people got. So if you look at these scores here, in terms of convenience seeking, we've got a average score of 4.75 within our sample. So we're generally a little bit higher than the midpoint of 4 on convenience seeking. Impulsiveness, we're a little bit lower than the midpoint, so not particularly impulsive. Price consciousness, we're really quite high at 5.12 on price consciousness as a sample, or at least the individuals in the sample were quite high. Down here, social orientation towards shopping is the average is 3.6, so it's a little bit lower. Across here is in this final column is a standard deviation. I find a lot of people skip over standard deviation because they don't quite get what it means. Now, one standard deviation will help you. The standard deviation will help you to understand what the distribution of the scores for that construct looks like. So here is standard deviation for convenience seeking of 0.805 indicates that 0.805 either side of that mean, so plus or minus either 8.05 either side of that mean, will capture 68% of scores. Right? So if you've got a very small standard deviation, like 0.01 or something like that, it means the scores are really closely clustered around that mean. And if you've got a much higher standard deviation, say that was 2.3 or something like that, it would mean the scores are much more widely spread around that, that mean. So let me show you what that looks like graphically. If we go up here to graphs, legacy dialogues, and then histogram. So if we go to convenience seeking, for example, and move that into our variable field up here and click OK, what we see is the spread of scores that people produced within our data set. So here you can see the mean is 4.76, and that corresponds to the convenience seeking mean up here of 4.76. So we've got an average about here, and then further and further away from that mean you get fewer and fewer scores. You can see here the standard deviation is 0.805, which corresponds to our standard deviation up here, which means that 0.805 either side of that mean captures 68% of scores. So if that was a very small standard deviation, 0.1 or something like that, it would mean 68% of scores would be very closely clustered around that 4.76, and there wouldn't be, it'd be a very tight, thin distribution. If we had a wider, a larger standard deviation, say 2.3 or 3 or something like that, what it'd indicate is scores fall much more widely around that mean. So what the mean and standard deviation tell us is, in general, what the average score is, but also the shape of that distribution, how tall it is or how flat it is. And this is quite important for when we get to inferential statistics, because the shape of that distribution is really what's going to dictate the way we perform some of those tests, such as t-tests. Now, when we see a distribution like this, where you've got what we call a bell-shaped curve with an average in the middle and then scores falling, fewer and fewer scores falling further and further away from the mean, what we say is that that's a relatively normal distribution. Right? A normal distribution is one where we've got most scores falling around the mean and then fewer and fewer scores falling further and further away. So let me just show you an overlay of a normal curve over that to show you what I mean by that. So a normal distribution would look perfectly like that, and you can see with convenience seeking it follows closely that trend. Now, a lot of our statistical tests or inferential statistical tests rely on the data being shaped like that, and a lot of the constructs that exist in the world actually follow that pattern. Most people on average are about the same, and then we get fewer and fewer people further and further away. And you can think about other instances like that. So think about something like weight or height. Most people tend to fall around a mean, then you get shorter and shorter, fewer and fewer people who are shorter and shorter, fewer and fewer people who are taller and taller. If we look at a few other variables here, you can see that it's a fairly consistent pattern. So if you look at risk aversion, for example, you can see it's also fairly normally distributed. If you look at for example, impulsiveness, you can see it's also fairly normally distributed. So that's quite reassuring to know. So running one of these tables gives us a lot of information very quickly about each of the constructs within our sample. So you can tend to report that information for your reader in a table of descriptive statistics. Another thing that you can report as part of descriptives is what we call frequencies or counts, which really tells us how many people fall into each of the key groups that we're looking at. So if you look at this table, it doesn't really tell us how many people we had who were male or female, older, younger, in a relationship, not in a relationship, and so on. So what we need in order to access that information, which is also descriptive, is what we call frequencies, a frequency table. So a frequency table will tell us how frequent those options were chosen. So for example, we want to know how many people are in the younger and older cohorts. We want to know how many people were Australian versus not Australian, male versus female, in a relationship, not in a relationship, how they access the internet, and type of communication used. If you click OK for each of those, you can see here you've got the information on that laid out very quickly and very clearly. See, with the generational cohort, you can see we had 224 younger people and 212 older people. So that's quite informative for a reader to know the breakdown of that generational cohort within our sample, but it's also reassuring for us as a researcher, as the research team, because we know that we aimed to collect approximately equal younger and older people based on the way students were instructed to collect data. So that played out in that data. We also asked people to collect roughly equal numbers of men and women, and you can see here it didn't quite make that same 50-50 split, which is fairly normal because we split based on surname, so that's never going to be perfect. But within our sample, we can see we had 240 men, 193 women, 2 people who were who indicated other, and 1 preferred not to say. Down here, you can see there's 157 single people, 276 partnered people, and so on. So frequencies are also another way to show or describe your sample to a reader. Another breakdown with frequencies that's also handy to use is what's called a crosstab. So what a crosstab does is take frequencies one step further. A crosstab basically provides a table with 2 variables crossed. For example, if we want to know how many younger and older people fell into the male and female categories, we could say we want rows to be the cohort variable and we want columns to be the sex variable. For example, we click OK, and you can see down here, down the bottom, you've got in the younger cohort, you've got 123 men, 98 women. In the older cohort, we've got 117 men and 95 women. And you can report that in your analysis or your report as well, or instead of just basic frequencies, because you can see that that split becomes quite informative. You can do that with a range of other variables. So for example, we could say relationship status, or we might want to look at preferred communication mode on the internet, and you click those, click OK to run those, and you can see here in terms of single and partnered people in the younger cohort, most people are single and fewer people are partnered, so 136 single people and 87 partnered people, which is probably quite expected within a younger cohort. And then you see the reverse happen when we look at the older cohort, where we see only 21 of the 210 older people being single and 189 being partnered. So exactly what we would expect. As people get older, they tend to partner up, but it's the flip of what we see with the younger cohort. So because that's intuitive, we tend to have more confidence in our data that it's been collected appropriately. Similarly, down here we can think about if people indicated they prefer email to communicate online versus instant messaging, and how that differs across the younger and older cohorts. Very few people in the younger cohort preferred email, and most preferred online messaging, so 18 versus 204, so that's a huge difference. And then within the older cohorts, it's roughly equally split, so 109 preferring email and 100 preferring online messenger. And so again, that really corresponds to what we would expect based on our understanding of how the world is, and how people who are older or maybe younger are more familiar and more tech savvy with online messaging, as opposed to older people who have more grown up with email. All right, so if we go back to our document here, you can see I've described all of that within the slide. So I've said a descriptive statistics table is quite helpful. We can also think about generating frequency tables to inform us about the counts or the frequencies within each of the key groups that we want to look at or want to compare. And what you do is talk about this in your report so that the reader understands what the nature of your sample or your data set is. And then over here we've said crosstabs are also quite useful. Now, one of the final things that you can do in your descriptives analysis section is come back and draw a table or produce a table or a graph, I should say, like this, of the age that people are within our sample. So one of the key things that we looked at, as you'd know, is the split, or we collected data based on having a split of older versus younger people. And if we look at that graphically, which is probably a really good way to look at it, because it jumps out at you so quickly. If you look at age graphically, what you see here is that at that 40 split, most of the younger group really fall in that far end, close to the minimum of 18 age bracket here, and then within the older age group, so 41 plus, being a bit more spread. And you can think about why that might be based on the nature of the people collecting the data and who they might have sampled. So that, something like that would be really important to comment on in your report. So you might produce a table or a graph like this and then comment on that. That's going to be quite informative and useful to flag, because if we're doing an analysis to talk about younger versus older people, what we would actually hope to be doing is comparing a wide spread of older people with a fairly wide spread of younger people. But in reality, what appears to be the case is that we're comparing very young people within that group to the older people, older cohort. So we're not getting many people from about maybe 27 through to 40 at all. So you can think about whether or not that younger group is really represented appropriately. All right, so that's your descriptives and a good quick rundown of what we would gather within SPSS to inform our descriptive statistics write-up. So when you're writing this up for your report, remember, mostly it's just a few sentences to describe what's going on in your sample or your data set for the reader, and then what you would do is supplement that with tables. So you can save a whole lot of word count by using tables that contain a lot of those numbers that we've talked about. So in the descriptive section, what you're going to do is briefly describe the key characteristics of the data set, talk about what is the final overall sample size after cleaning, the mean number of people within each of the groups of interest, so men versus women, older versus younger, if they're groups that you're going to be talking about, and then the means of the key constructs that you're going to be talking about as well. So often, as I said, they're going to be within a table. Now, I talk about means here, but usually you'd put means and standard deviations as well, so that people have a good idea of what the underlying distribution looks like. So as I said, you use a lot of tables, but what I would suggest is that when you come to producing a table, use your own word processing document or Excel or whatever platform you want to use to create your own table. What we see is with a lot of students is a bit of a lazy approach, where people will talk about, say, 224 and 212 people in each of the younger and older cohorts and simply paste the table in from the analysis document. That's not really how professional reports are done. Okay, so when you produce a table, ensure that you include only the information that's relevant, and ensure you refer to that within the text to make sure the reader looks at it. So for example, if you paste this in, you've got frequency, you've got percentage, a valid percent and a cumulative percent, and you don't need all of that information. Think about what you would see in a professional report. Those tables or graphs, if you want to use a graph instead, tend to be tailored for that report and report specific. Okay, so do make sure you go into a word processing document or a spreadsheet package or program and produce your own tables or your own graphs based on what you want to report. when you do include a table or a diagram or a graph or a figure within your report, make sure you always refer to it within the text. Okay? Give the reader a reason to look at that and explain what's going on in that table. Don't just leave it up to them to interpret. So that's the other key point that I would recommend there. So within this video, we've gone through cleaning and editing the data. We've talked about descriptive statistics, what they are and what they do, and how a reader uses them to understand what a data set or a sample looks like. I've gone through and shown you how we can arrive at some of the numbers for that through SPSS and where that came from, those numbers in your analysis document came from. In the next video, we'll move beyond that to talk about inferential statistics, specifically correlations and t-tests that will allow us to address the 3 research objectives for your quantitative project report.